this is for it on video, is slow-mo.
That'd be really long.
Alright, so here we go. Find the coordinates of the vector with a magnitude of 3 in the same direction as the vector -2, -3. So we got a vector that looks like this. That is over 2 down 3. It looks just like that. How long is that vector? What is its magnitude?
9 plus 4.
9 plus 4 should be the square root of 13, which is 3 point something. 13 is in between 9 and 16, so it'd be between 3 and 4. Now, would you agree that there is a vector in the same direction of this as this one whose length is 3? I mean, that makes sense, right? Your job is to find what are his coordinates. The original is -2, -3. That has a length of root 13. But you want that same direction, but you want to shrink it up a little bit.
Would you divide everything by 3?
No, but you're at least in the right direction. Could we make this a unit vector?
Yes.
Yes. How do we do that? Divide it by root 13. So, -2 over root 13, -3 over root 13 is the unit vector, so its length or magnitude is 1, right? If you take something whose length is 1 and then times it by 3, now isn't it going to be 3 units long? So to get the vector whose magnitude is 3, we first of all make it a unit vector, which we know how to do, divide by its magnitude, and then times everything by 3. That vector has a magnitude of 3. So basically here, if you can open your minds and really think about this for a second, I can give you any vector, and you can give me one back in any length you want, right? If I give you some random vector like 5, -1, and I say I want the vector whose length is 4 in the same direction as this one, what are you going to do first? It's a 2-step process. First, you're going to do what? Make it a unit vector by dividing by its magnitude. So what would the unit vector for this be? 5 over root 26, -1 over root 26. That vector has a length of 1. Now, for whatever reason, you want it to be 4. So you're simply going to take this guy and times him by 4. So 20 over root 26, -1 over root 26. Okay? So how do we change the length of a vector? We make it a unit vector and then multiply by whatever length we want.
Do you not care if there's a square root or pi or fraction?
Nope, there's a reason we maybe prefer that actually. If you don't, if it's making you a little uneasy and you want to rationalize it, go right ahead, but you do not have to. Okay, all right, last problem refers us back to our book. So let's get our books out. If you brought your book. If you didn't, shame on you. I can't imagine going through the day without my math book. All right, this sounds like a GTQ, guaranteed test question. So let's read number. Am I interrupting something back there? I'm talking about a guaranteed test question, and you're like, I don't know what. Clark, where have you been, my friend?
Sure, Miss Moore. I totally forgot what time it was. I was just sitting with anyone from this class, and next thing I knew it was 25.
You need to bring me a box of Kleenex, Clark.
Alright.
Or, and I'm talking about tomorrow, or that becomes a detention. Okay? Rachel.
Is this chapter 6-1?
It is, section 6-1. We are on page 512, looking at problem number 44. Alright, so here we go. This is what you were talking about earlier, because now we got a plane flying on a heading. So we got to think back and remember what we learned about that. This is 44. So here's my compass. And he is on a heading of 170 degrees. Now remember, when we're doing compasses, this is the situation. So we've got a plane flying on a heading of 170 degrees. So that would be like this, at 460 miles an hour. Now, I put the 460 there as though it's the magnitude of the vector, and it could be the magnitude of the vector if we only let the plane fly for 1 hour, right? Does it say? No. We're going to let it be 1 hour. So we're going to look at 1 hour's worth of action here. So this is 170 degrees. Now, before we go on to the next step, because what's happening, boys and girls, is what? The plane is flying, but the wind is blowing. Now, most of you probably haven't flown a plane. I mean, actually, like piloted a plane. But you've all driven a car, you've all ridden a bicycle. And what happens when you're on your bike and you're going against the wind? What happens? You go slower, slows you down. So when the problem talks about what is the actual ground speed, it's saying this wind is going to have an impact on the plane. Now, if it happens to be blowing right behind it, it will speed it up. But if it's blowing at it somehow, it's going to slow it down. So this is our task. We got the plane flying, got the wind blowing, got to figure out what's actually happening. So my suggestion to you is the very easiest way to do this problem is to stop right here and find the components of the airplane. So what I mean by components are the X and the Y. Remember we found those earlier? Now think about what we know. Here's our airplane. I'm going to make a triangle. As always, it's a butterfly bow tie. That's the only way I draw my triangles in math class. I know this is 460. I'm going to take that out because it's kind of in the way. That's 460. Do I know this angle right here? That would be 80? How do I know it's 80? 170 minus 90, right? Could I find, I'm going to take this 170 out. Could I find the X and the Y that go with the airplane? Sure I can. Let's find X first. What am I going to say? Cosine 80 equals X over 460. So X equals 460 cosine 80. I'm going to use a couple more decimal places. I got 79.8782. Did you? No, I didn't get I got 79. Am I right?
Yeah.
Now I'm going to find y, and I'll do y the same way, only that will use sine. So y equals 460 sine 80. $453.0116. Why did I put a negative in front of it? I didn't get a negative on my calculator because it's going down. When I'm dealing with directions, vertical is vertical, but some vertical is positive and some vertical is negative. This vertical is negative. That's why the picture really helps me. Why is my x positive? Because it's going to the right. Okay, so here are the components of the plane. Now guess what I'm going to do? Find the components of the wind. So here's my wind. 200, so that's going to look like this. This is going to be 200 degrees, I'm sorry, 200 degrees. And the magnitude of the wind is 80. This is the same problem. We can put both vectors into the same problem, but then you have to do a lot of geometry and messing around. It is just easier to find one vector at a time. So find the vector coordinates for the airplane. Now we're going to find the vector coordinates for the wind. So our bow tie triangle, straight up. How big is the angle this time? 70. Right? We're just going to figure that out because we're smart people looking at the picture. And I need x and y. So we'll find x and y the same way. All right, so go ahead and do that. Tell me what you get for x and y. I got both negative. I marked both negative. Was that a good idea? Do my numbers look like yours? Okay, so let's see what the question says. Question A was find the component form of the airplane. That's this. This is question A. Those are the components for the airplane. What's that? The components for the wind. They didn't ask me for that, but I need it. Because question B says, what happens in reality when we put both of these forces together? What's the result? What's the resultant when we put both of these forces together? What does resultant mean? We add. So we're simply going to add these two vectors together. And that's easy. You add their x's and you add their y's. So what do we get as the resultant force? Got to keep the negatives.
Are you putting in this one?
Yeah. I could have done it all in one step, but I thought that was too much for our first example. So I got that for the first one. And if I typed correctly, I got this for the second one. Did I I do okay, or did I make a mistake? Looks okay. Right now, what does the question say again? Find the actual ground speed and the direction. So let me look at what I've got here. I've got a vector that goes over 42 or 52 and down 528. So this is what my picture is. I'm not putting the actual all those decimals in. I guess I can. And I want to know the actual ground speed. Isn't that this? That's its magnitude. So I want to know what that is. And I want to know its actual direction. So basically, I took these two vectors, I changed them into their component form, added them together, and now what am I going to do? Take them out of their component form. Find the magnitude and the direction angle. Well, the direction. So here we go. Pythagorean theorem. I got a magnitude of 530.79. Did you? Or maybe you didn't, maybe you started with the angle, I don't know. How fast was the plane supposed to be flying? 460 miles an hour. What's this wind doing? Pushing him. He's actually going faster than he was before. Brenton, you're looking at it strangely. Did I make a mistake?
No, it's just I'm getting error.
You're getting error.
Because you do 52 squared, you do that squared. Squared.
Plus that squared.
Yeah, I
Don't
did
put
that.
a negative.
Oh.
Yeah, you don't want the negative to get squared out. Don't put the negative in there. Now, how am I going to find the angle? The direction.
You can do second tangent or second sine.
I'll find this angle right here, and I'll use tangent. I like tangent because, I don't know, it's less round off there, I guess. So the tangent of that angle is going to be 528.187 over 52.5166.
So you gotta do second tangent.
So I'd have to do second tangent. That's how I find an angle on my calculator. I got 84. Did I type in that right? I'm afraid maybe I missed a decimal point or two. 84.32. Now, is that the direction of the airplane? No, the actual direction would be 90 plus that. So the actual direction of the plane is 174.32 degrees. So remember, originally, we started out trying to fly 46 miles an hour on a course of 170, but now we have been blown a little bit off course, but we're speeded up a little bit. Right? Okay, so let me stop right there. I'm almost positive this will be a, well, it's a quest, but this will be a quest question. So let's talk about the steps we went through. There's a couple in your homework you'll do. Let's talk about the steps we went through to do this problem. You got the plane and you got the wind. So what did we do first? We found the X and Y for the plane. Then we found the X and Y for the wind. Then we simply added those together. X plus X, Y plus Y, easy. That became the components of the resultant, of the answer. So then we had to do the Pythagorean theorem to get the magnitude, to get the actual speed. And then we did some right triangle trigonometry to get the actual direction. Okay, follow all those steps, Michael.
Up there when you found the angle for
didn't he use -5 to 8?
Okay, it doesn't matter. I don't want this angle. This angle will just come out to be negative. I know it's in quadrant 4, so I know it's going to be a negative angle. I just care about how big it is. So if you put the negative in, it doesn't matter. It will not show up in your answer. It's just ignore it when it comes up. Because it will, I mean, if you type in the negative, it's going to come out a negative.
Gotcha.
All right, everybody good? Okay, in your packet now, because you have not had enough, turn the page, and you see something called Precal A First Vector Quiz. Turn the page, skip a page, and you see something called First Vector Quiz. All right?
What is our question?
I don't know, we have to get through 6.2 and 6.3, I don't know. But our first vector quiz, maybe tomorrow. All right. Are you on the page that says first vector quiz? Okay, we'll get on the page that says first vector quiz. Here we go. I want everybody to do problem number 1 right now. Find the coordinates of vector AB. Look back at your notes if you need to. Hopefully you don't need to. And then I want some nice volunteer to come up and put the answer on the board for all to see. And for everyone to ask a question if you have a question. Okay? So, number 1, markers all warmed up, ready to go.
Jack Myers.
Look at Jack, he's awesome. Jack is going to write the coordinates of vector AB on the board, and you're just going to check him, see if he's right. Is that 2 and 6?
Yeah.
All right, what do you think? Is 2, 6? Is that what you put?
Yeah.
Yes. You guys, you're going from point A to point B. You're perfect. From point A to point B. So, by the way, senior night, Saturday, or senior afternoon, or whatever it is, Saturday. Come support Jack. You're going from 1 to 3 in the X direction. And you're going from -2 to 4 in the Y direction. Perfect. Absolutely beautiful. All right, number 2. Giving you a couple vectors there, V and U. And you're going to do V plus 2U. So I need a volunteer now to come up and put number 2 on the board, Jason. And I'd like to see your work up here, so why don't you not do it there, but do it up here? Because there may be a little bit of work we need to show for this one. I would probably show a little work. All right, what do we think about Jason's work? He's right? So 2 times U is 10-2. And then just add that to D, just like we added the wind and the airplane. That's what you're doing here, just adding them together. Beautiful. Number 3. We aren't ready for it yet. So we're going to hold off on that one. That will not be on your first vector quiz. Well, the interesting thing about vectors is there are a couple of different ways to multiply. There's what's called the dot product, which is what this is, and there's what's called the cross product. So the symbol you use changes the way you do the problem. So that's a discussion for tomorrow. We'll do that tomorrow. Number 4, somebody should, so I'm not going to quiz you over stuff we haven't talked about. So you do not need to worry about number 3. But number 4, you do need to worry about. Who can come up and put the answer to number 4 on the board for us?
It's easy.
It is easy, so why aren't you doing it?
Maybe, eh?
You waiting for a hard one, is that
Yeah, I
it?
thought it would.
Okay.
Come on now.
Oh, wait, what's the problem?
Here. What do you think? He said the opposite of you is -5, -1, and he's exactly right. Kids, if you goes right 5 and up 1, then the opposite of you is going to go back 5 and down 1. Jack?
For the answers on those ones, do you have to put little arrow things?
You have to have parentheses or arrows. You don't. It doesn't have to be arrows. Parentheses are fine.
Okay.
Yeah, parentheses are fine. You can't write them without something around them, but it doesn't have to be little arrow things, no. All right, number 5. Who's gonna come up and do number 5? What does number 5 mean? What are we doing in number 5? Magnitude, length. So somebody come up and do that. God bless the center of the room, because the outsides here are worthless today. Come on, somebody volunteer. Clara, thank you. You don't need a calculator to do number 5. No way, Jose, you are better than that. What? You need school supplies and all those Sometimes the truth hurts. Perfect. She says root 13. You might not want to just ignore that negative. I don't want that to confuse you. Remember, every time you find magnitude, the negative's going to square out. So it's okay if you write it, but don't type it in on your calculator. Don't get confused. The negative is going to disappear every time you do magnitude because you're squaring. Okay? Now the bonus, which won't be a bonus if it shows up because we've discussed it. We've talked about this problem. So let's see if we can sort it out together.
You want me to do it, Miss Ward?
I would love for you to do it, Brenton Anderson. Now, I do need you to be kind of talking about what you're doing as you're doing it, okay?
Alright.
So like you are the teacher,
Okay.
okay? And maybe you'll be so good, you'll just tell me not to come back. Just let Brenton take over.
So, what?
You need to shave though if you're gonna be a teacher in my school, okay?
Should I write out the problem?
Yeah, you know. All right, now, Brenton is putting himself on the line. This is a much more complicated problem than the other ones we did. So let's see if you can figure it out. I see some heads down, working on the problem diligently. That's good. Everybody should be making an attempt.
Okay.
All right, so tell us what you've done so far.
So far, I just found A and C. It's at the top. 43 and then you times 2.
Okay, so let's wait to make sure everybody's caught up. We need vector AC. So would everybody agree that the vector from A to C is 4, 3? Starting at A, going to C, 4, 3. So it has a 2 in front. And oh, by the way, what's the name of that 2? It's called a scalar. And so he said, okay, 2 times 4, 3 is 8, 6. Is everybody all right so far? Okay, so now he's ready
Okay.
to do the next, or actually the last part now.
So now you're gonna have, looking at the nose, you go from B, which is 3, 4.
Mm-hmm.
And then, I guess I can draw it out. You find like the distance.
Well, put 3, 4. Put 3, 4 on there, because you know that's where you're starting.
Okay.
You're starting at point 3, 4. Yeah, let's just put a point. Yeah, now the rest of that might get too confusing. All right, so he is starting at the point 3, 4. That's B, point B. He needs to find a new point, D, so that the movement from B to D is the same as this right here. So he's going to start at B, move 8, 6, and where's he going to end up? That's the question. Where does he end up if he does that? says 11, 10.
No way. Wait, are you looking for D?
Oh, Mallory's thumbing up. The question says find D.
Oh, yeah.
D.
That's D. That's point D.
But
Why do you have a thumbs down?
Because you got magnitude of 8.6, and so.
Okay, now, don't use the word magnitude. You have to have a direction of 8,6. So we're gonna start at the point 3, 4,
Yeah.
and we're gonna move right 8 and up 6. So if you start at 3, 4, which is point B, and you go right 8 and up 6, where are you gonna stop? There we go. So work out what's confusing you about that.
I don't know, I think I was gonna get
He's trying to move from 3-4 to 8-6 instead.
Oh, yeah, no, good, okay, yeah, I understand that. 8-6 is not a point. See, this is where it gets a little confusing. 8-6 is not a point. 8-6 is the coordinates of this vector. 8-6 describes a movement. The point is 3-4, the initial point, and your job is to find the end point if you moved 8-6. Does that make sense to you? All right, so now I understand what you were doing. All right, so at this moment in time, you should be able to do your 6-1 homework. There are quite a few problems there. I would strongly recommend you get started on it.
Is the answer 11, 10?
The answer is 11, 10. It's point D.
Well, isn't that what we were trying to solve?
We're trying to find point D.
Yes, that's the
11,
final.
10 is the answer.
Yeah.
Yeah.
Edward, let me give you a charger. Thank you.
Is it still on? I'll say. Oh my god, I just gave that.
No. This is that's how many steps you have to take.
Miss Gordon, can I have my 2 stickers? I remember going on here.
Okay, yes. Did you turn that off?